Welcome. We will continue randomized complete block design. Randomized complete block design RCBD. So, in this lecture I will first show you one example and then how the parameters are estimated, including SST, SSE, SS treatment and SS blocks. So, in last lecture you have seen the ANOVA table for RCBD. We have seen that there are three sources of variation with one fact treatment, that is treatment, block, error, and then this is what is the things, and the right hand side SST equal to you got sum, double sum y I j square minus y double dot square by n equal to basically a b. Then you got, we found out SS treatment, this we found out that 1 by b sum total I equal to 1 to a y I dot square minus y double dot square by a b. Similarly, SS block we got 1 by a sum total I equal to 1 to a y dot j square minus y double dot square by a b, and SSE will be SST minus SS treatment minus SS blocks, and degree of freedom for this is a b minus 1, for this one is a minus 1, this is DOF degree of freedom, and this is b minus 1, and this one a minus 1, b minus 1. You have seen this. So, also you have seen that MS treatment we calculate, this is SS treatment by degree of freedom, and MS error is SS error by a minus 1 and b minus 1 degree of freedom. Then you have seen that we have computed F0, which is SS treatment by degree of freedom by SS error by degree of freedom, that means MS treatment by MS error, and that follows F distribution with a minus 1 into b minus 1 degrees of freedom. So, we will see one example, some kind of tutorial. Here the example is a medical device manufacturer produces vascular grafts. This is known as artificial veins. These grafts are produced by extruding billets of resin combined with a lubricant into tubes. Controllable factor is extrusion pressure that affects the occurrence of flakes, which is basically defect. However, the resin is manufactured by an external supplier and is delivered to the medical device manufacturer in batches. So, that means different batches of resin is used to manufacture this. So, and this resin is supplied in blocks in batches, and the quality of that batches are beyond your control, because it is coming from the supplier side. That is what is the situation. The engineer suspects that there may be significant batch to batch variation for the resin supplied. The product developer decides to investigate the effect of 4 different type of extrusion pressure on flakes using randomized complete block design, considering batches of resin as blocks. This the response variable is yield, that is means that is a good product versus minus the defective products, that sense, and or the percentage of tubes in the production run that did not contain any defects, means any flakes. So, the data once you get, that means there are extrusion pressure is the controllable factor, it is having 4 different levels and there are 6 different blocks, and you have done the experiment under each block. All the level of extrusion pressures experiment is conducted, and this is what is the data on the yield value y. So, and then you see that right hand side, this is the total. So, y 1 dot is the total, means y 1 dot is 556.9. Similarly, y 2 dot is 550.1 and y 3 dot is 533.5 and y 4 dot is 514.6. These are all row totals. Similarly, if you go by column totals, you will be getting y dot 1 equal to 350.8, y dot 2 equal to 359.0, y dot 3 equal to 364.0, y dot 4 equal to 362.2, y dot 5 equal to 341.3, y dot 6 equal to 377.8, and sum of these will be y double dot, which is basically 2155.1, which is also sum of these equal to 2155.1. Fine. Then you will calculate SS total. So, what is the formula? SS total double sum, then y I j square minus y dot dot square by a b. So, I here I equal to j equal to 1 to 6, I equal to 1 to 4, and all those values if you combine, you will ultimately this value means the square of all those 6 into 4 24 observations. So, when you sum up, you will get the value 193,999.31 minus y double dot is 2155.1 square divided by AB is 24. So, this quantity is 480.31. Okay. Similarly, if you want to calculate SS treatment, what is this formula? The formula is 1 by B, sum total I equal to 1 to 4 here, or 1 to A, y I dot square minus y double dot square by A B. So, in this case 1 by 6, sum of I equal to 1 to 4, y I dot square minus this quantity 2155.1 square divided by 24. So, what you do here, how many totals are there? Row totals, 4 row totals are there. So, this is basically 556.9 square, 550.1 square plus 533.5 square plus 514.6 square divided by 6 minus 2155.1 square divided by 24, and then this quantity will become ultimately it will become 178.17. In the same manner, if you calculate SS block, this will be 1 by 4, sum total of, that means the your column square, that is T 350.8 square plus 359.0 square. So, like this the sixth one is 377.8 square minus 2155.1 square by 24. SS total is 31, SS treatment is 178.17, SS block is 192.22, then what is SSE? From here you will get SSE equal to 109.89. So, you are in a position to compute the ANOVA table treatment, extrusion pressure effect, sum square 17 this, block this, error this, total this, their degrees of freedom 4 treatment level minus 1, 4 minus 1 3, then 6 batches 6 minus 1 5, and error is 5 into 3 15, a minus 1 into b minus 1, and there are 24 observations and then 24 minus 23, then you are getting mean square. Now, F0 is 59.39 by 39 divided by 7.33, that means F0 is MS treatment by MSE 59.39 by 77.33, which will be 8.11. So, F0 is MS treatment divided by MS error, which is 59.39 by 7.33, this equal to 8.11. So, if we consider 0.05 is the threshold, then it is basically 3 and 15, because this degree of 315, this value is 3.29. Now, this value is much less than 8.11, which is equal to F0. So, reject H0, reject H0. So, there are treatment differences. On the aid. Fine. So, this is what so far we have computed. Now, we have I have given you the model y I j equal to mu plus tau I plus beta j plus epsilon I j. What is the estimate of this, what is the estimate of tau I, what is the estimate of beta j, what are the error estimates and all those things. In addition, that how that means the computation we have shown from partitioning, but from regression approach also we can find out SST, SS treatment, then SS error. First, I will see that how the parameters can be estimated using regression approach. So, our model is y I j equal to this and I equal to 1 to A, j equal to 1 to B. In regression approach, what we do? We want to minimize SSE. That means, in this equation epsilon I j equal to y I j minus mu minus tau I minus beta j. If I take square, this will be square. If I take sum, double sum. Okay. So, j equal to 1 to B and I equal to 1 to A, then here also double sum, j equal to 1 to B, I equal to 1 to A. Suppose this is the function L which we want to minimize. Then what you do? You know the parameters. So, del L by del mu, del L by del tau I equal to 1 to A, and del L by del beta j, j equal to 1 to B. If you differentiate and put them equal to 0, put them equal to 0, here one equation, here A number of equation, here B number of equation. So, A B plus B plus one number of equation you will find out, and and then the equation will be like this, you see. So, all normal equation, one normal equation related to mu will be like this. So, the left hand side, these are the estimated value and the sample, that means the levels for blocks and levels for treatments. It will be the grand total. Then we have a number of tau I. So, tau 1, tau 2, tau A. You see that everywhere that mu is coming because of this, B mu is coming. For tau 1, the tau 1 quantity is coming, and beta j all will be coming beta 1 to beta b, and this will become y 1 dot, that is first row total. Tau 2, the left hand side accordingly changing, second total, tau A similarly this, and then all the column totals. So, if you see that in the first equation a b mu cap plus, if you take common b here, this will be, suppose I consider the first equation with reference to mu, the equation is a b mu cap plus, if I take b common, then it is basically I equal to 1 to a tau I, and plus if I take a common, it will be j equal to 1 to b beta j. So, this cap, these are all estimated value, this becomes y dot dot total. Now, we have two constraints because of the design, because of this design tau I equal to 1 to a equal to 0 and tau b beta j equal to 1 to b cap, this also becomes 0. So, if we put this becomes 0 and this also becomes 0 from this, then you are getting a b mu cap equal to y dot dot. So, that means mu cap is y double dot by a b, which is nothing but y double dot by n, which is your grand average. So, what we have observed earlier, you are basically reproducing the same thing using regression approach. Okay. Now, if you see the second equation here for tau 1, you see it is basically tau 1 related equation is b mu cap plus b tau 1 cap, then plus sum of b j cap j equal to 1 to b, this equal to y 1 dot. So, what about this? This is 0. So, if that means you are getting tau 1 cap equal to y 1 dot by b minus mu cap, where mu cap is y bar and this is y 1 bar. So, that means y 1 dot bar minus y double dot bar. So, this is the row average minus grand average. That way we have seen. So, if I put here I, it will be I, it will be I. In the same manner, we will get beta j cap, we will get y bar dot j minus y bar dot dot. So, this is what you see the equations are coming. So, tau I is this, I equal to 1 to a, for beta j, j equal to 1 to b. So, I mean through regression approach you are also getting same equations. Okay. So, now from the data you can find out all those things, estimated values tau I, tau beta j and other things, and once beta j and beta all those things are estimated, then you are in a position to estimate epsilon I j, which is for every y I j will be subtracted by mu cap, will be subtracted by tau I cap, will be subtracted by beta j cap. So, in this example what happened, we have 4 extrusion pressure and 6 number of blocks. So, we have 24 observations. So, we will be getting 24 epsilon I j cap, which is known as 24 residuals. Because you have already computed this, you have computed this, you have computed this, and you know this value. So, that means every cell value will be subtracted by the corresponding the grand mean, then the row effect and the column effect. Column effect, row effect, this. Okay. So, now you can do that row effect is what? So, that means if I want to know what is the epsilon 1 1 here, then this will be y 1 1, which is already there, minus mu cap is y double dot bar. So, minus tau I is nothing but y 1 dot bar minus y dot dot bar. The minus y dot 1 bar minus y dot dot bar. this is what for beta j. So, then this is y11. So, this quantity minus plus, so this will be cancelled out. So, now this is minus y1 dot bar minus y dot 1 bar plus y dot dot bar. So, that means this quantity will be error residual will be computed yij this value, then minus this value, minus this value. So, I can write like this, I can write like this, a general one I can write. Suppose here it is yij, suppose, and this is your y I dot bar, this one is yj dot bar and this is y double dot bar. Then epsilon ij cap is this one, this will be minus, this also will become minus, this plus. So, yij minus this plus this. So, that sense all residuals will be computed. This is what is the computation part from it is as you want. In assignment you will be doing it and then you will learn more. Now, I will show you the actually we have computed SST, SS treatment and SS error. Here we will show you the concept of from regression concept how it is coming. So, we will use the concept called that full model and reduced model concept. So, what is the variability that can be captured by full model? The full model means all parameters are considered. Suppose if we do not consider the treatment and blocks and all those things, then only mu is there, that is a reduced model. We may consider that mu and tau, this is another reduced model. So, this is full model, this is reduced model, and another one will be mu beta, another reduced model. Now, suppose if you do not consider any model, then we will see that ultimately we thought of that like this, that sum of y I j square, this is what is the total total sum observation square is there, and then if we use a model, then their sum square will be their sum square deviation will be from the full model will be with respect to this, with respect to this, with respect to this, and if we subtract the raw sum square minus the reduced model that what sum square that is having, then this difference will give you the error part. Like we know that epsilon I j equal to will be y I j minus mu minus tau I minus beta j. So, that means y I j minus mu plus tau I plus beta j. So, what I am saying that the sum square here is SSE, this sum square here will give us some kind of SST, and this one will basically that reduction due to full model, reduction part due to full model. So, this can be denoted like this, this is basically our this will be equal to that one r mu tau and beta. So, here I am saying that with reference to y I j only, not y I j minus y bar or mu. So, that sense it is there, but if you subtract this mean this one, then you will get the other kind, that formula that what we have discussed earlier, sum y I j square minus y dot dot square by n will come, because you will consider this. So, this part we have discussed earlier also, but approach is this. So, then what happened, this is the this is what is the full model reduction in reduction of variability. So, what we are doing, we are using the model estimate like y I j, you are using, it is mu cap plus, suppose y I j cap I want, then this is equal to mu cap plus tau I cap plus beta j cap. This is what is coming, and then we are, when we are writing like this r mu tau and beta, we are multiplying this mu cap with the total for that parameter. Similarly, how many tau I we have? We have some tau I, means we have tau I equal to 1 to a, that you multiplied by the corresponding total, and then plus beta j cap with corresponding total j equal to 1 to b. This will give you the reduction in variability. Now, see the slides. So, the estimate of mu cap is y bar, this one is y I dot bar minus this, and beta j is y dot j bar minus this. So, if you do algebraic manipulation, all those things, you are finally getting this one. That means I equal to 1 to a this, j equal to this. Now, if you subtract this quantity from the sum square of the observations, that means this minus this, sum square of the observations minus sum square because of the model, the difference will be SSE. So, you are getting this equation, and actually earlier you have seen this equation, earlier also you have seen this equation. Now, if I want to calculate that what is SS treatment, then what we will do, we will simply find out, we want to find out, then we will find out that, so this is the full model. Now, here what happened, we will find out that if we keep mu and beta instead of tau, then this is the reduced model without tau, and the corresponding reduction of variability will be this. So, then what is the contribution of the treatment? The treatment combination will be the full model minus the reduced model. This full model treatment combination you have seen earlier, this is the full model treatment full model reduction is this, and then minus this is this quantity, this is nothing but this, and this is what we have seen, that when we are computing SS treatment, we are writing y I j square by b minus y dot dot square by n equal to a b. Okay. So, that means if you want to know SSE, then what happened, you require to know sum square of the observation minus r of tau, mu, tau and beta. If you want to know SS treatment, then it is nothing but r tau beta minus r mu and beta, because this portion is eliminated from here. Similarly, if you want to know treatment blocks, then you find out r mu tau beta minus r mu tau. If you want to know the SST, then you write down that what is the y I j square total minus r mu, how much is coming from mu. Anyhow, so all those things from this regression concept approach, from regression approach we can estimate. So, you see what happened here, reduced model is this, you are getting the sum square treatment. If you want to get the sum square blocks, your model is without block, what is the thing, and then what is the reduction in variability without block is this, and then this minus this is this. Similarly, you will get SST also. So, I hope that you have understood that means the estimation of parameter in this particular case RCBD, and I will go back to the numeric example just to give you some idea how the numerically it will be computed. So, here you see, suppose you want to know what is you will be able to compute tau 1 cap. So, I know tau I cap is mu I cap minus mu cap, which is nothing but y I dot bar minus y double dot bar. So, if I say what is tau 1 cap, then you will say y 1 dot bar minus y dot dot bar. This is nothing but 556.9 minus what is the grand mean, grand average, just let me check. Okay, we have not computed here, but it will be 2155.1 by 24. So, this will give you value of tau 1. Similarly, you will get value of tau 2, tau 3, tau 4. If you want to know beta j cap, then this is nothing but y dot j bar minus y double dot bar. For example, I want to know the beta 1 cap, although beta 1 cap, then it is y dot 1 bar minus y double dot bar, which is y 1 dot bar is 350.8 minus y double dot bar is 2155.1 by 24. Find out this value. Same manner other beta you will be able to do. Suppose you want to know the error component E11 bar for the particular cell, then this will be y11 minus y1 dot bar minus y dot 1 bar plus y dot dot bar. So, y11 is 90.3 minus y1 dot bar is okay. So, here one mistake we have done, 556 is the total divided by 6. Similarly, here this is basically the total divided by 4. This is total value, not average value. These are the average value. So, this by 6 minus this by 6 minus this. Okay. So, 90.33 minus y1 bar, y1 dot bar is 556.9 divided by 6 minus the column average 350.8 by 4 plus 2155.1 by 24. This quantity find out, that will be the error. So, using this table, go to slide. So, using this table you will be able to find out if you compute average here across rows, across columns, then grand average, then just subtract the row average with grand average, you will be getting the level effect, treatment effects for different levels. If you do it for the blocks also, that effect you will be getting. Now, when you are interested to find out the errors using this model, is that cell value minus this corresponding row average minus corresponding column average plus the grand average. In this way, all the parameters can be estimated. Okay. So, once the parameter estimated, the next issue is that the RCB, the errors or residuals are no estimated. So, you have to go for residual analysis. For what purpose? For test of assumptions. What are the test of assumption? First one is normality, second one is your homoscedasticity, third one is independence, uncorrelated errors. So, all those things, the way we have discussed in one way analysis of variance, in the same manner you can do it. You go for normal probability plot, quantile plot of the errors. You will see that whether the errors are normally distributed or not. Second one, homoscedasticity, predicted value versus residuals you plot. If there is the funneling right or funneling left, that kind of effect is there, then the heterogeneous variability. So, that is then another issue. And for independence, you have to know the order of experimentation. X axis you write down the order of experimentation from 1 to that n, capital N. Y axis you give the error values, residual values, and you see that whether they are random or not. If they are random, then that is independent. Otherwise, you can go for Darwin Watson test for errors, that is taking one lag at a time. You can find out DW, Darwin Watson, and also their correlation coefficient there, and from there you see that whether the correlation coefficient is large or not, and accordingly you will be able to do the residual. So, for RCBD residual analysis we will not do further. This is the same way in CRD, whatever residual analysis we have done using one way ANOVA, the same way you will be doing, and once you have residuals calculated, residual analysis eventually. Okay. The thing are basically taken from Montgomery book, chapter 4. Thank you very much.